Today we're going to take a look at examples of single event probability questions. This first question says that from 3 teachers and 21 pupils on a school trip, one is selected for a free prize. What is the probability that a teacher will be selected? So we have 3 teachers plus 21 pupils, giving us 24 people on the trip. So we have a 3 out of 24 chance of selecting a teacher. And if we divide the top and the bottom by 3, 3 into 3 goes once, 3 into 24 goes 8 times, gives us a 1 in 8 chance that the winner will be a teacher. So here we have another question. From the snooker balls shown, one is chosen at random. What is the probability of selecting either a red or a green? So this time we can either choose 3 reds or 1 green out of a possible 10, which gives us 4 out of 10, and we should always try and simplify. So we divide by 2. 2 into 4 goes 2 times, and 2 into 10 goes 5 times. So the probability of choosing either a red or a green is 2/5. Part B asks, what is the probability of not selecting a red? Well, if there are 3 reds, that means that there must be 7 that are not red. So it's just 7 out of 10. Probability questions sometimes involve playing cards, so you should familiarise yourself with the number of cards in a deck. There are a total of 52 cards divided into 4 suits. The suits are just a different type of card. So we have 13 spades and 13 clubs. These are the black cards. We have 13 hearts and 13 diamonds. These are the red cards. Here's a typical probability question involving cards. From a pack of playing cards, what is the probability of randomly selecting A, a king, B, a red queen, C, a 9 or a 10, and D, a card that is not an ace? So, what's the probability of selecting a king? Well, we know in a pack of cards we have a choice of 52. And we can see here that we have got 4 kings. So it's a choice of 4 out of 52. And we try and simplify this. So we divide the top and the bottom by 4. 4 into 4 goes once, and 4 into 52 goes 13. So the chances of getting a king is 1 in 13 chance. Then B asks us the probability of getting a red queen. Well, again, there are 52 cards in the pack, and we have got 4 queens, but only 2 of those queens are red. So we have a 2 in 52 chance, and again we simplify. Divide by 2 is 1 in 26 chance of getting a red queen. Question C asks us the probability of getting either a 9 or a 10. So again, we've got 52 cards, a 9 or a 10. Well, there's a 9 and a 10 in each of the 4 suits. So that's 8 possible cards that we could select. So 8 over 52 is our probability. And we simplify by dividing by 4 this time. So 4 into 8 goes 2 times, and 4 into 52 goes 13 times. This gives us a 2 in 13 probability. Question D asks for the probability of a card not being an ace. So, like before, we have 52 cards in our pack. We've got 4 aces, which means we must have 48 cards that are not an ace. And again, we divide by the highest factor, which in this case is again 4. So divided by 4, 48 divided by 4 is 12. And 52 divided by 4 is 13. So the chances of selecting a card that is not an ace is 12 in 13. And here's one last example of a probability question. A letter that appears in the word magician is selected at random. Give the probability of selecting A, the letter G, B, the letter A, C, either G or A, and D, any letter except A. Well, we can see that the word magician is made up of 8 letters, but only one of these letters is G. So we have got a 1 in 8 chance of selecting a G. For B, what's the probability of getting the letter A? Well, we can see that there are 2 I's in the word magician. So we've got 2 opportunities out of 8 letters, and we simplify by dividing by 2, which is a 1 in 4 chance. Question C asks for the probability of getting either a G or an A. Well, we can see that we have got 1 G and 2 I's, so that gives us 3 out of 8 chance. We could have also got this answer by adding the chances of getting a G and the chances of getting an A together to give us our 3/8. The final question asks us the probability of selecting any letter except for A. Well, we can see here that we have got 2 A's, which means that 6 of the letters are not A. So 6 out of 8 are not A. And again, we always try to simplify, so we divide by 2. 2 into 6 goes 3 times, and 2 into 8 goes 4 times. So there's a 3 in 4 chance that we would select any letter except for A.